summarize, right? Yes. Say what? It's like the second time you've left the room. Go ahead.
You did gonna say go ahead. I'm dead.
I'm not going to argue. I'm just saying I'm making a mental note that I hear you. I know that happens. I'm just concerned that you're leaving and we're going to summarize now. So summary, water, right? So water. By the way, did you notice that I answered the question in that study guide about water? Yes? Top right hand, you were supposed to put the partial positives and negatives around salt. Did you see that? At the top? Did everybody fill it in?
No, I don't have my paper.
Oh, that's too bad. If only your teacher would have told you to put it in a binder and have a binder with all your notes and all your handouts in the binder. Oh yeah, your teacher did tell you to do that.
I don't have the binder. So.
You have to have a 3-ring binder. You don't have a 3-ring binder?
I have it, but it's not here.
Oh, not very helpful. Are we good? All right. What other questions did they ask you there? Somebody want to give me their handout? Unfortunately, I gave my last one out. Why isn't your handout? Why isn't your? Give it here. No, let me give it his because he's not even using it. Why don't you have it out, man?
I had it out, but I had just put it back.
Okay, I was about to say we're going. Oh, this is where we're going over this stuff. You want to make sure you get this stuff right. You should read these, right? You should actually read. See, there's paragraphs here. It says water is the most abundant molecule, of the smaller molecules making up living things. Typically makes up about 2/3 of any organism. Water is a liquid at room temperature, and many substances dissolve in it. You see all that stuff what we covered? They made it real simple, didn't they? I wasted my time here explaining all this because they wrote it here, didn't they? It's all written for you. But did anybody read that and understand it right away? Okay, that's why we go through the detail. All right? It's a great question. I just want to make sure we understand this. Water is a liquid at room temperature. Many substances dissolve in it. It is a medium inside cells and aquatic life. Water takes part in, and is a common product of many reactions. Water molecules are polar and have weak attraction for each other and inorganic ions. What kinds of inorganic ions? Sodium and chloride are 2 examples. We'll talk about what inorganic and organic is in just a moment. Forming large numbers of weak hydrogen bonds, it is a feature that gives water many of its unique properties, including low viscosity and chemical behavior as a universal solvent. So we talked about universal solvent, why it is. We filled in the circles. Everybody agree? Okay. Now, something else you should know about water is it holds heat very well. It has a high, what we call high specific heat. I'm not going to go into it. It's in your book. Everybody knows, I've said it many times, you have a book. It's on your web page. You can look at specific heat, right? Let's go ahead and look at the web page so you can see it. And no one has a question as to what things are available for you. I don't know what it is. Where is the book? My bookmarks aren't here. Don't know why. So there it is. You go to Honors Biology. You go to first marking period. Go to week 2. Go down. There's a chapter. There's a periodic table. There's the chapter. Open it up. There's all the stuff we talked about. There again, I didn't have to go into all this detail. I could have just assigned you the chapter and gave me a quiz on it, couldn't I? So, anyways, properties of water, section 2.2, properties of water. You can even click, there's a review at classzone.com on this. Hydrogen bonds, cohesion, adhesion, solution, solvent, solute, acid, base, pH, right? There's water as a space-filling model. Do you agree? H2O, yes? Instead of lines, they put little balls, they stick them together, positives and negatives. There's water, hydrogen bonding with each other. There's surface tension, we talked about that. Cohesion and adhesion. So water is a universal solvent. Water is polar. Like dissolves like. Yeah, I know you can't see what I'm writing right now, but I'm writing it all down for you in the video. I'm recording as well so you can watch it yourself, and when you're home you can pop up your book in front of you and compare it. So specific heats is, water's hydrogen bonds give it an extraordinary specific heat for water, for a molecule its size. So this is very important because it allows you to deal with all the heat that you produce, and on a really hot day, your body temperature doesn't change very well, doesn't change very much. It allows the Lake Erie not to freeze all the way through. Water holds its heat. It takes a lot of energy to move, to change water's movement. Remember, what is heat? I want to remind you what heat is. Heat is average, what? Kinetic energy. Average energy of motion. So, or I should say temperature is, I'm sorry. So temperature is average kinetic energy, and so it's hard to increase the temperature of water. It takes a lot of energy to change to change the movement of water, to increase how fast water molecules move, because what? Yeah, but what's that partial negative, partial positive doing to one another? What do they do to one another, the water molecules? They attract. So it takes a lot of heat, a lot of energy to move it. So that's why water has a high specific heat. Cohesion is that stickiness. Don't put anything away, I'm writing it down, but you need to write it down as well. Cohesion is that, should I just switch over to what I'm writing down? Yes. Cohesion is water sticking to itself. That's cohesion. And we said that happens. Adhesion is water sticking to other things. An example is a test tube. If you look at a test tube, next time we're using the test tubes, and you should have seen this already. What you'll see is the water doesn't just make a flat line. Water does this. It sticks to the sides. Do you see that? Why does water stick to the side of the tube? Why does that happen? Because of adhesion. Because water's sticky. It sticks to the side. Hey. Yes?
Just warning.
Tomorrow we'll talk about acids and bases, but for today, we know we've talked about adhesion, cohesion, specific heat, and tomorrow we'll talk about acids and bases, and we're done with the properties of water. We'll start to talk about organic molecules and the biomolecules. I think we're gonna have to send more kids out to collect recycling, obviously. I have one person I need to see, I need everyone else. If you guys see the recycling crew, tell them we need to wrap it up, because I can't send them late to another class for recycling.